morning, class. Welcome to today's lecture. I'm going to take you through MMA 414 Fourier series. And our topic today is the periodic functions. We shall begin with the definition of the periodic function. So we begin. A function f is said to be periodic with period p for all x if f of x plus p equals to f of x. And you should remember where p is the least positive constant. So the second part of the definition is where you are going to get everything else to be correct. Where p is the least positive, we can denote it as p greater than 0. So let me give you an example of a question about periodic functions. The question is given f of x equals to sine x, find the period p of f of x. So this question is very simple. And kindly observe on how you are going to go through the question. Solution. We first of all write the formula. F of x plus p equals to f of x, which implies that sine of x plus p equals to sine of x. So in this case, we shall recall the calculus identity of sine. So the calculus identity of sine is sine of a plus sine of b equals to sine a cos b plus sine b cos a. Applying it in our question, it will be sine over, instead of a, we shall replace with x, plus instead of b, we shall replace it with p, which is our period that we want to find, which is equals to sine of x cos of p plus sine of p cos of x. So in this case, recall that p is the least positive number for our formula f of x plus p equals to f of x to apply. So in this case, if you look at our question, sine of x plus p equals to, let's see, the least value of p. Remember, p cannot be 0. So, and because these are trigonometrics, the sine and cosine, we shall go by 0. We go with pi, 2 pi, 3 pi as we proceed. So this one, 0 is out because 0 is not included in the periodic. So we substitute with pi. If you put pi in the cos of pi, so cos of pi is cos of pi equals to -1. And if you take -1, you multiply by sine x, you'll get negative sine x, which will not agree with our condition here. So pi is excluded. We now go to 2 pi. If you find the cos of 2 pi, cos of 2 pi, you'll get 1. And because cos of 2 pi is 1, if you come and substitute it here, cos of 2 pi, you'll get this part is 1. So 1 times sine x is sine x. If you substitute here, sine of 2 pi, everything will collapse down to 0. So in this case, we shall remain with sine of x times cos of 2 pi plus sine of 2 pi times cos of x, because the sine of 2 pi will be equal to 0, so everything else here will collapse to 0. And because the cos of 2 pi is 1, our solution finally becomes sine of x plus 2 pi, where 2 pi is our p, will be equal to sine of x times 1 is just sine of x. So which implies that our period for our function f of x equals to f of x plus p equals to sine x equals to 2 pi as required. Thank you for watching, and please subscribe.